So mass spectrometer and ionization energy assignment. First 18 questions are recorded. So we'll start with question 19. Every session I will solve at the end of a session, I'll solve some questions from different assignments from both unit 1 and 2. So that will be a revision for you as well. And you will have an idea how to answer these structured questions. So starting with question 19. Question 19 is a multiple choice question. A p block element in period 3 of a periodic table react to form an ionic compound. What could be the electronic configuration of the ion formed by this element? So first thing, period 3 elements means they should have 3 shells. And it's a p block element. When we talk about the blocks, like we have group 1 and 2, these are the s block element. Then we have group 3, 4, 5, 6, 7, and 8. These are the p block element. So what p block element include? P, like the outer shell electron is in a p. And here this is a s block. Between them there will be d block, and we have f block elements. So from group 3 to group 8, these all are p block elements. And they mention it's a period 3. Third period is there. So, and it is forming an ionic compound. So the term how it is forming an ionic compound can be formed by transfer of electron. When atom transfer electron, it will form an ionic compound. So what could be the configuration? So how we identify the configuration? Because if we talk about if it was, because the only possibility, first shell, you will have in exam, you will have the periodic table. Like example, the first shell, you will have hydrogen and helium will be there in the first shell. The second shell, you will have lithium is there. Like the second period, you will have lithium is there, then beryllium is there, then boron is there. And the third one, and so on, like boron is there, which is 5, carbon, nitrogen, oxygen, fluorine, neon. Then the third shell, which elements we have? We have sodium is there, and magnesium is there, aluminium is there, silicon is there, phosphorus, sulfur, chlorine, and argon. These are the elements. So the element, because they mentioned this is a period 3 element and it's a p block, so we are left with this side. Now it cannot be argon because argon does not react, so we are left with 5 choices: aluminium, silicon, phosphorus, sulfur, chlorine. Aluminium, how it will react? The aluminium, when it will react, it will lose all the valence shell electron, because aluminium is like 30, but it will lose it all the 3 last electrons, so we are left with 10 aluminium electrons. And 10 electrons of aluminium, what will be the configuration? It will be 1s2, 2s2, 2p6. Means there will be no third shell electron. Like, because what might happen, if the metal is reacting, it will lose all of its third shell electron. And if a non-metal is reacting, all these non-metals are reacting, they will complete the octet. Like they will complete the third shell. So all the ions of these, all of them, like example, silicon, phosphorus, sulfur, chlorine, when they will form the ion, they will form 1s2, 2s2, 2p6, 3s2, and 3p6. They should complete, because the octet should be complete, or the third shell should have 8 electrons. So when we check the options, why A cannot be the answer? Because if it was it should be either a complete third shell, because when element is reacting, when they transfer the electron, either if it's a metal, then it will lose all of its valence shell electron, and if it's a non-metal, it will complete the valence shell to complete that octet. So in this case, this is wrong because S is having 3. This is the right one. Why? Because the third shell is complete. So B is the right answer. Why not D? D shows that like C. Why C is not the right answer? Because it shows that D is complete. And why this is wrong? It shows that another shell is also complete, like 4s. But electron is, it should be in the third period. This will be an answer if they ask mention about the p block element of the fourth period, not the third period. So B is the right answer. Why B is the right answer? Because when we have period 3 element, either they can lose all the third shell electron or they gain the third electrons to complete octet. So in this case, the third shell is complete by 2 and 6. That's why B is the right answer. Is it clear? So same question can be there related to period 2 as well. They can, like example, ask for period 2. So if they ask that about the period 2, so what might happen? It will lose all the electrons. It will be the loss of electrons from the second shell, or it will gain electron and complete the second shell. Question 20. The period 2 elements have the highest with the highest melting point. So when we move across the period, what will happen? Like period 2, we have lithium is there, beryllium is there, boron, carbon, nitrogen, oxygen, fluorine, and neon. So first 4 groups, as we move across the period, the melting point increases. And then the melting point decreases. Why it increased for the first? Because the type of the bonding, like lithium, beryllium, boron, they will have a metallic bonding. This will have a giant covalent structure. And they have a simple covalent. So first 4 groups, it increases. So even aluminium, why it's wrong? Because it's not there. Boron, carbon, even silicon is wrong. So you're left with boron and carbon. So carbon should have the highest boiling point. The next is a structure question. This question is about the element sulfur. Complete the diagrams to show the electronic configuration for a sulfur atom. Include the labels for each subshell. So how you can complete sulfur? You can check the periodic table first for sulfur atomic number of a sulfur. Sulfur is 16. So it will be 1s2, 2s2, 2p6, 3s2, and 3p4. So this is 1s. 1s is already done for us. Then we'll write 2s. And one will move clockwise, another anti-clockwise. Then we'll have 2p. First they will occupy singly, 2p, x, y, z, and then they will pair up. Then we have 3s. 2 electrons are there, one clockwise, anti-clockwise, and then we have 3p. So first we'll occupy singly, and then the pairing will start. So there are 2 unpaired electrons in the p orbital. And this is given in terms of energy. Then write an equation for a first ionization energy of a sulfur. Ionization energy means energy needed to remove electron from a neutral gaseous atom. So how much energy we need? State symbols are also important. So sulfur atom turn into sulfur ion. Whenever ionization energy is there, it should always be a gaseous substance, like, and don't forget to write the state symbols as well. Explain why the first ionization energy of a sulfur is less than the first ionization energy of both phosphorus and chlorine. To answer such type of question, the best thing is electronic configuration, because like sulfur is there, phosphorus is there, and chlorine. Sulfur is 16, we just wrote 1s2, 2s2, 2p6, 3s2, 3p4. Phosphorus is 15, so 1s2, 2s2, 2p6, 3s2, 3p3. And chlorine is 17, 1s2, 2s2, 2p6, 3s2, 3p5. First, the comparison between, because they have the same shielding effect. All of them have the same shielding effect, because this is 3p, this is 3p, this is also 3p, but the number of electrons. Here, what happened in the 3p orbital? In the 3p orbital of a sulfur, it has 4 electrons. But in a 3p orbital of a phosphorus, there are 3 electrons. Because phosphorus is 15, atomic number is less than sulfur. So when the electrons are arranged, there is a pair of electron in sulfur as compared to when phosphorus, there are all single. So it means uh, like this electron will be much more easy to remove. So in all these cases, we are removing the electron from the same shell. But why phosphorus has a high, greater ionization energy than sulfur? Because in phosphorus, there is like in sulfur, there's a pair of electrons, so they have more repulsion. So first thing, what is the common? We are removing electron from the same shell for all of them. So as we are removing the electron from same shell, but why we observe that the sulfur is having a low ionization than phosphorus? What is the reason? Because there is a pair of electron which has greater repulsion compared to phosphorus, in which there is no pair of electron in the p orbital. And why chlorine have a high ionization energy? Even in a chlorine, there are 2 pairs. When we draw the p orbital of the chlorine, so for p orbital of a chlorine, there will be 2 pairs are there. Even though 2 pairs are there, they will have more repulsion. But when you check the nuclear charge, sulfur is having, like, atomic number is 16 and nucleon number 32. So 16 protons are there. Where chlorine is having 17 protons. So 17 protons are pulling these electrons. Here 16 protons are pulling. So 17 protons have a greater attraction compared to 16 protons. So or you can also say that chlorine contains greater nuclear charge because it has a greater nuclear charge. So as a result of a greater nuclear charge, it has more attraction towards the valence shell electron. So phosphorus and sulfur, why there's a small difference? Because sulfur has a pair which experience more repulsion. But even though chlorine has 2 pairs, there will be more repulsion, but that repulsion is less as compared to attraction of the 17 protons. As a result, it will have a high ionization energy, chlorine. A sample of a sulfur containing 4 isotopes. What is meant by the term isotopes? Isotopes mean they have the same number of proton atom of the same element with same protons but different neutrons, different number of neutrons. Then calculate the average mass of sulfur. So how to work out the average mass? The percentage of the isotope multiplied by its mass plus the percentage of the isotope multiplied by its mass plus the percentage of the isotope multiplied by its mass plus the percentage of the isotope. This was 34 plus the percentage of the isotope multiplied by its mass. And the total is divided by 100. That will give us the average mass. You will just calculate and get the average mass of these isotopes. If fractions are given, we'll divide by sum of the fraction. Mass spectrum of a sample of a sulfur 32 as the only isotope shown. So sulfur 32 different peaks are there. Calculate the number of sulfur atoms in one molecular ion. So this we have sulfur 32 and we want to calculate how many atoms will be there in this, as we have the mass spectrum is also shown. So what is the what peak we will take? We'll take, because calculate the number of sulfur atoms in a molecular ions. So which one we will take? Will molecular ion peak, we take the highest one. So highest one is 256. Most of them are 64, but highest one is, and what is the mass of one sulfur? Mass of one sulfur is 16. Oh, sorry, 32. Proton number is 16, mass number is 32. So it will be 256 divided by 32. So we'll get 8. It means that will be sulfur 8 or S8 atoms will be there. Like 8 atoms of a sulfur, maximum 8 atoms. These are different molecules of the sulfur. Like what does it mean? It means like here we have S only, here we'll have S2, here we'll have S3, S4, S5, S6, S7 and S8 is there. But S7 is not there. There's no peak for S7. So these are different molecules of a sulfur. Sulfur molecule have different number of atoms, but they ask number of sulfur atom in a molecular ion. The molecular ion means the peak with the highest mass is called a molecular ion peak. So in that case, we took 256. If the same question was there, they ask calculate the number of atoms in the base peak. Base peak means the one which is having the highest number, highest percentage or relative abundance. So in this case, the base peak is 64. So we'll take 64 divided by 32. Suggest the formula of the most stable ion. So what is the formula of the most stable ion for the sulfur? As you can see here, 64 is the base peak, which is the most. So the most stable ion for the sulfur is S2. And you should don't forget to write the charge. 1 mark is for writing the charge, most stable ion like S2, and 1 mark is for writing a charge, the formula. So this was the question 21, like we did from 19, 20 and 21 from the mass spectrum and ionization energy. Any question or a doubt related to the session today? As we did, we started a new topic which was about group 2 and 7. Group 2 we completed. Next session we'll do group 7.